The best test takers who consistently score in the top 1% are no different than you. What's their secret? They use key tactics that propel them to the top of their class. Dr. Jubal, MedSchoolInsiders.com. I didn't always score in the top 1%. I used to be exactly where you are. For me, it was memorization. No matter how hard I tried, I could not keep the facts in my head. I thought I had a limitation in my brain that gave me lower than average memorization skills, whereas it simply came naturally to others. It wasn't until later into college, when I was studying for the MCAT, that I built my memorization skills and learned the science behind memorization. Through my own trial and error, I determined the study tactics and test-taking strategies that propelled me to achieve a 99.9th percentile MCAT score and a near-perfect 4.0 GPA for my BS in neuroscience, widely considered one of the two most challenging pre-med majors at my university. And once I had the secret sauce, I was able to apply these techniques to medical school, which kept me at the top of my class and earned me a spot in plastic surgery, the single most competitive specialty to match into at the time. If you want to become a test taker who scores in the top 1%, the tactics shared in this video are going to move the needle for you dramatically. The first tactic is honing your test-taking mindset. If you're the kind of person that consistently scores worse on your real tests compared to practice tests, you'll find incredible benefit from developing this one strategy. It may sound simple, but that doesn't mean it's easy. This tactic is difficult to implement, but it's incredibly powerful when you do it right. And I'm not talking about any woo-woo crystal magic here. This is actionable and will have immediate concrete benefits to your performance. How you mentally approach an exam significantly impacts your performance on it. Instead of allowing anxiety to get in the way and cause you to freak out, adopt a mindset that empowers you. Take a high-stakes exam like the MCAT. The pressure to do well is massive, and the stress can easily get the better of you if you let it. So instead, reframe the surge you feel to enhance your focus. When you're about to take an exam and the stakes are high, your sympathetic nervous system kicks in, pumping you with various hormones like cortisol and adrenaline. Your physiology changes. You feel stressed, overwhelmed, and under pressure. But when you reframe that, it can enhance your focus. I used to think of every exam as a challenge, a game designed to test your limits. Instead of focusing on what could go wrong, I embraced the opportunity to push myself and see what I was capable of, like earning a 90% when everyone who took Dr. Nelson for biochemistry said anything above 80% was impossible, or testing my limits to see if I could set the curve in organic chemistry or physics. Rather than anxiety-provoking and scary, I reframed it as a challenge I wanted to stand up to, and I got hyped. I found that the stress actually sharpened my concentration, consistently leading to better results on actual exams compared to practice tests. The heightened stakes acted as a catalyst, allowing me to perform optimally under pressure. It's this same reframing of pressure as a focus sharpener rather than as a source of overwhelm that will allow you to sink 4 in a row during beer pong rebuttal and get you into overtime time and time again, earning you various nicknames like the Resuscitator and Dr. Clutch. When you're feeling stressed and your sympathetic nervous system takes the wheel, remind yourself it's there to heighten your senses and sharpen your focus. It's telling you that you've got this. The second tactic is thinking in extremes. I've always been a better test taker than a memorizer because even with incomplete information in the middle of a test, I could reason my way to the correct answer. One of the ways I did this was by thinking in extremes. If the question is asking you to change a variable by 2% and you're not sure what will happen next, hit pause. Don't think about a 2% change, think about a 1000% change. This provides much more clarity as to what smaller changes could mean, which is especially helpful for physics, chemistry, and math tests. First, identify directionally what's happening with a large change and then scale that back with a smaller change. For example, an object with a mass of 4 kilograms is accelerating at 5 meters per second squared under a constant applied force. If the mass of the object is increased by 15% while the applied force remains constant, what is the approximate percentage change in the object's acceleration? 1. You could apply the equation force equals mass times acceleration and work through the variables. Or if you don't remember the equation, you could still arrive at the correct answer by using real-world examples and thinking in extremes. Think of a massive increase instead of only a tiny increase. What if the mass were 1,000 times bigger? What if it were 1,000 times smaller? If you kick a soccer ball and all of a sudden it weighs 10,000 times more than a normal soccer ball, what do you think is going to happen? It's obviously going to move a lot slower. Even though you may not remember the specific equation, you can reason through it by thinking in extremes. This quick mental shift helps you instantly see the inverse relationship. You see that with the same force, a huge mass has a tiny acceleration, and a tiny mass has a huge acceleration. The next time you're stuck on a test question, consider the options in the most extreme terms to exaggerate the possible outcomes. The third test-taking tactic is holes in understanding. Essentially, you're asking yourself, what else would have to be true for this answer to be true? If you're stuck between two or more answer choices, go through each answer choice and play out that question. What else would have to be true in order for this answer to be correct? Here's how this could play out during a test. The question is, a student observes that when a plant is placed under a red light, it produces more oxygen bubbles than when placed under a green light. Which of the following statements best explains this observation? A. Green light provides more energy for photosynthesis than red light. B. Red light is absorbed more efficiently by chlorophyll than green light. C. Green light is used to heat the plant, which speeds up oxygen production. Here's how to apply the strategy. What else would have to be true for A to be correct? If green light provided more energy, the plant would produce more oxygen under green light, not less. This contradicts the observation. Also, plants reflect green light, which is why they appear green. Therefore, you can rule out A. What else would have to be true for B to be correct? If red light is absorbed more efficiently, it would provide more energy for photosynthesis, leading to increased oxygen production. This matches the observation. What else would have to be true for C to be correct? Green light would have to be absorbed by the plant in order for it to heat the plant. However, since we see plants as green, we know they reflect green light. Also, heat increases all reactions, not just oxygen production, and while I could make some assumptions to justify this answer choice, I'm having to make more generous assumptions compared to answer B. Therefore, you can rule out C, so B must be the correct answer. When you're unsure, don't let panic set in. The last thing you want during a test is to get overwhelmed by one question. You may not know the answer at first, but there's a lot about the world, science, and the human body that you do understand, so use your logic and critical thinking skills to arrive at the most likely answer. The fourth tactic is inverse thinking, deliberately considering the opposite of a statement to test its validity. This is especially helpful when you're stuck between two answer choices that sound similar or equally plausible. When reasoning forward isn't working, reasoning backward can expose flaws or reinforce your understanding. Let's walk through a concrete example. The question is, which of the following best explains why patients with diabetes often experience increased urination? Option A, glucose causes increased water reabsorption in the nephron. Option B, glucose pulls water into the nephron, increasing urine output. And option C, diabetes causes the kidneys to shut down water filtration entirely. If you're unsure, apply inverse thinking. Ask, if this answer were false, what would that imply? Does that make sense? Let's test A. The inverse would be, if glucose does not cause increased water reabsorption, maybe it causes decreased reabsorption, or even water loss. That sounds more in line with what we know about osmotic diuresis in diabetes. Glucose in the nephron pulls water in, not out. That makes A suspicious. Now let's try B. The inverse would be, if glucose does not pull water into the nephron, then it wouldn't increase urine output. But we know glucose acts as an osmotic agent, drawing water in and leading to more urination, so B fits and its inverse doesn't. Now C. The inverse would be, if the kidneys don't shut down filtration, then they're still filtering water. This is true. Filtration doesn't stop entirely in diabetes. C is an exaggeration and can be eliminated. By flipping the logic of each choice, you're essentially pressure testing it. Weak reasoning cracks under that pressure, and strong logic holds up. Top test takers use this reverse method to reveal contradictions and expose the flaws in distractors. It's like proofreading for logic. The next time you're stuck, think, what's the inverse of this answer, and does it make any sense? We have a few additional test-taking tactics that we couldn't fit in this video, but they're included in our free test-taking cheat sheet. You'll get all tactics mentioned in this video, plus a few additional tactics and tools used by the top 1% of test takers. Click the link up here to get it absolutely free, or check the link down in the description.